So now I guess everybody can hear me. So hi again. I'm Eugene from JetBrains, and this part of the talk we're going to speak about DSLs. I'll explain what DSLs are, but I was created this page and say, okay, this is how I would start my presentation, but then I thought, hey, that's going to be a presentation about DSLs, so it's kind of boring stuff. And this would be the right thing for a DSL presentation. And the trick is that this one is a valid Kotlin, and it will work for you. And so I hope I will be able to explain how these tricks work. And of course, it's statically typed and so on and so on. So this ended up having kind of a good bytecode at the end, or good JavaScript code at the end, or even good native code at the end, depending on what target you work with Kotlin. And as for me, join us on Twitter. I'm Eugene Petrenko. I'm working at JetBrains for a long time. The confession: I'm not from a Kotlin team, but the clarification is the link here on the word user. I'll tweet my presentation so you can take a look. But trust me, I'm using Kotlin for such a long time, for 4 or 5 years, depending on which year it's now. And you might take a look. I've written something on my blog at JetBrains. I'm doing server-side. Of course, I'm doing Kotlin. So I developed some kind of a deficiency. I start typing in Java file, and OK, it doesn't work. Oh, I'm typing in Kotlin. Then I switch to a Kotlin file, and then continue typing in Kotlin. It works, and so on. Besides the server-side and Kotlin, I'm doing Toolbox app. You have an idea what Toolbox app is? Oh. So ping me. I have several stickers for Toolbox. So I would be happy to share. And Toolbox, if you don't know, this is a kind of tiny app. It really helps to manage all IDEs you like to be using. So I use 5 IDEs. And this really pain when all IDs getting updated, and if I see an update, I have only one link here, just update. And the second trick is the projects, so it shows all the recent projects along your machine for all IDs you have. I really like this one. Okay, DSLs. Well, to start presentation about DSLs, one need to take a look at the definition. Let's start from a definition, kind of boring stuff, maybe. So I decided to check with Wikipedia. And this text is about Wikipedia. It's saying, OK, there are languages which are OK for anything. There are languages which are OK for something. And DSLs are kind of languages which help you to deal with a specific domain, meaning, OK, you're dealing with the business rules of some bank, or you're trying to test some sophisticated things, or you're trying to build some graphs for your application. And that's why you are likely to use some specific language. Why? Because you can express your ideas easily. You don't need to write the piles of code in a general purpose language. And technically, I would split the DSLs in 2 parts. The one part is the specific DSLs, the DSLs which are created like years ago, and there are a number of examples. For example, so the SQL is a kind of a specific language we all use to deal with the SQL database, or regular expressions, really nice language to deal with text searching or pattern matching or replacement. Yet another example can be the state machine. So for example, if you're doing with native C development, you may create a state machine language which helps you to program the embedded hardware easier than dealing with the bare C. And the problem of such languages is that it's really hard to implement, to use. If you start dealing with such a language, you need to do parsing, lexing, compiling, all that stuff. If you decide to just grab some existing custom language, you would need to solve the problem, how would you use it in your build process, if you have a decent IDE to work with that, and so on. That's kind of a pain. And there is another part, tiny part of DSLs. At first, it's a Fluent API. So if you're trying to explain some domains in Java language, you'd rather create some tiny library or tiny API which helps you to deal with the domain. And in this case, you're trying to embed or create your DSLs with an existing technology. You don't need to recreate the whole process as long as you use the same language. And my favorite example here is the Fluent APIs. I was Googling for it, and this one is for Java. So if you're trying to render some RTF, it's kind of a library called RTF something. In the comments, I have a link. The comments for this slide. And this is yet another example. I created it 4 years ago. The idea was we were struggling to test how the application works with some graphs. In this case, it's the up source and it's graphs of commits in your repo. And to test this, you need to define this graph in your test. And it's a little bit, from one side, it's kind of good. Here, I can explain what I need, like in a readable thing. You can understand what I mean here. But the worst part is that I still need this comment with a picture, with explanation. And as for DSLs, as for DSLs, it's really nice to be able to express what you mean in a way that everybody can understand it without extra explanation. And if you're thinking about DSLs, this is yet another DSL. And this is, again, a valid Kotlin program. It does not implement the 100% basic language, but still looks like a basic language. And I'll explain later on how you can create this. So for me, DSLs is the way to speak the language you want to speak without spending time on the rituals of your programming language. And in this case, for example, if you realize that you're, say, business people or somebody in your team, they are so like to speak to you in a basic language. OK, let's do this. I hope you won't. I hope you won't implement this one. But if you need a specific language to define your specific things, so you can invent something which helps you. And it's easy to express. So I mean that if you need to, for example, to build that graph for your test, you can implement it easily. And if you're sharing this code to somebody, I hope they would be able to understand you again without any explanation, definitions, and so on, and to understand the information. And of course, there are a huge set of examples like this. For example, a friend of mine, he created a tiny DSL in Kotlin which helps to generate the YAML file for Kubernetes. You know something about Kubernetes? Some. OK, I hope it will work for you. OK. And at that moment, we're switching from the YAML files from Kubernetes. I get it. For me, it's exactly problematic stuff, to HTML. So let's say we're trying to create an application. No matter if it's client-side or server-side, but still, we need to use some HTML. And in the practice, we're likely to have some specific information in this HTML, like usernames, some weather, some, I don't know what exactly, but something we need. And in practice, we ended up having something like this. Or you might be using JSPs. OK, kind of stuff, a little bit better, but still, it ended up having this thing being compiled and work. And in reality, of course, there are a number of variables in this example, which helps you to lost yourself. And now, just assume that the goal is to fix this one. And if I would try fixing this one, there is a high chance, for example, I forgot to close the tags in the right order. If I change in many lines, for example, here and on real examples. And the trick is that we may consider something like this. So in Kotlin language, we can create a function allows me to define the same HTML in this way. And at least here, I would not forget to close the tags, because there is no chance to break the rule. Since the IDE helps, and a language and compiler, they helped me to make sure that at least it would be correct HTML file at the end. Maybe I'll screw up in a JavaScript on a CSS, but OK, less chances to screw it up. And if this one is done correctly, then IDE will help you. IDE will say, OK, here you can do something like this. And there you can do something like this. And if I try to do something which is not allowed, the IDE will say me, OK, here you see the error. And when I try to compile, again, the compiler will say, OK, it doesn't work out. It will not work out. And this is how DSLs work. And if we now switch to a Kotlin, what we know about this? The Kotlin is tightly typed language. It means that if you're trying to deal even with such a DSLs, the types will be checked. And you're likely to have the compilation error instead of the runtime error. It's really good. The syntax of language is done the way that you can benefit from DSLs. The language helps you to express yourself without extra sugar and extra stuff. And of course, there is IDE with a code completion. It helps you to implement DSLs easily, and it helps you to deal with DSLs. And as I mentioned before, you can compile Kotlin to a number of platforms, including iOS, Android, Java, JVM, native. I think I forgot some. Embedded devices. And that's kind of a moment that it's time to show you your code and to explain some details with ID. So I'm going to switch to ID. Are you able to read this one? OK. So I hope I can start this one. Yeah, it even works. Cool. So what we're going to do just now, here I have a Java application. So I intentionally created the Java model. So this is a main class. It's called Java Client. It contains several fields. So name, another name, company, a Twitter account. So Twitter account is one string, company is two strings. And of course, we have builders for it. So we are able to build this one. We are calling a function build, which creates this immutable classes for us. And say we have such a code somewhere in our existing part of our application, and we are not allowed to change it. So in I would assume that I cannot change it. And I have the main thing. Here I have a builder. So what is the trick? I have this code, which calls my API to create a class to fill up this hierarchy. And this one. So let's start turning this Java code into Kotlin code. So this code will rewrite in Kotlin. The rest Java code will stay the same. So the first thing I do, I just copy this one. So if you have questions, if you lost something, just ask at the moment you feel lost, and we will fix it up. So I just copy this code, and I go here. I would paste this one. And at that moment, IntelliJ says me, OK, it's time to convert something. It will not reinvent the DSL for me automatically, unfortunately. But it helps a lot. And now you may try to see the difference. So you may try to recall this, remember what you see here. And now I click in the button, and I see magic. I spot like 3 things to start with. The first one is val. Have you heard about Java 10? Yeah. In Java 10, you write var. And if you need the val, in Java 10, you write final var. This is how you do it in Java 10. But in Kotlin, you simply say val. So val is a final var if we're talking about Java 10. And the trick is that so this one declares the variable which you cannot change. So the rest works the same. So the type is inferred, so we know that this one, oh yeah, in Java you tend to write this way. Here, in Kotlin, you simply say the class name and constructor parameters. You don't need to write the new keyword. There is no new keyword in Kotlin. It's just a matter of taste. And if you, for some reason, need a type, you declare type this. So you might say, OK, I know the builder must be string, and then the IDE says, hey, there's something wrong here. Well, this is how you create the variables. The next thing in Kotlin, the property. So this is the standard thing for you. We used to have the beans in Java for years. And the idea is as simple as this. So if you have a set something method in Java class, then you can call it the way like it's a property. So if you have a get, you can read. If you have a set, you can write. There are properties readable, and there are writable properties. So of course, you can still try to say, you can still call this function in the old way. Even copy-paste doesn't allow me this. So I have to try. You can do this one. You can do this one, but you see here the highlight in the IDE says, hey, no. There's something you can improve here. It's the better way. OK. Now I want to start this application once more. And we see what it's printing out. Oh, now, this is my enterprise Java class, and someone forgot to implement it. Well, as I mentioned, I have no rule, no chance to update the Java code. And I need to help to solve this somehow. So I need to create a function. So I would call this I cannot call it toString because, OK, I can. toString. And this would take called Java client. Java client. Return something minimum. meaningful. But what's here first name? Okay. So, and of course I have a problem because I need to declare the return type of this function. So in Kotlin we have kind of consistency. All the time you specify type this way. You say column and type name. It works for function return types. It works for parameters. It works for vault. It works everywhere the same way. So like here, you see? And if here there are several tricks, and you saw some part of those tricks in the previous presentation. And the first one, if you don't need. Okay, so wow, what's up? Should I need this one? Oh yeah, it works now. So you see here, I can use this string template. So instead of concatenating things like we used to have it before, you can specify it as a string template. It reads a little bit easier, depending on your taste, if you like it or not. And if your function is too long for you, you can specify it with this way. And if you are still bored with specifying types, you can trust on Kotlin compiler, and it will help you. Okay. Okay, yeah. Now we can fix this one and say, and we need to call this toString function from client. So you may trust me, it would work, but it looks kind of, to me it looks kind of ugly. I would like to avoid saying the utility call. So this kind of utility function, I may put this toString function in my super duper utility function class. And here in this line 23, I would write in the whole name of this utility helper class. It's not that what I want, but my dream is here to say something like this is what I want. This would shorten the theme, and to create this one, I may create the extension function here. So it would work the same way. And the trick here, I would try to copy paste this one to show the trick. The trick is here with the foo. So I no longer have a variable called foo in this scope, but how would I access the receiver, the Java client instance? Exactly. So either this or even that. So as long as this is a receiver, so in Kotlin you use this keyword to access the fields of receiver or methods of receiver, and as is this keyword, you're allowed to omit it. And sometimes if you call several nested functions with the receiver, you can think, which exactly this I have inside, but it's a difference. Here it's easy. And if you have, you may remove braces if you like. A little bit easier to read. And this is not the best thing we can do. The best thing, and if we're talking about DSLs, the building a DSLs is a kind of a trick. You're trying to make the best out of the language syntax to solve the problem you try to solve. And for the sake of DSLs, I would like to have this one. Well, and to make this one, I can copy paste it. Say to debug. Let's call it to debug. And to implement this one, I need to say instead of fun, I say val. And here I need to implement the get function. So this one called extension property. So we have extension functions. Why don't we have extension properties? We are allowed to. And you can even have extension writable property. If you need it for some reason, you can say var here, and then you need to implement the set function. Once you do it, it would work for you. If you have some reason to do this, for example, you have ugly setter in the existing class, and for your context, you need something more readable, more useful, okay, go ahead, implement this one. And on a compile time, the whole thing is not complexer than just a call of a static function on some static code. That's it. So easy. But Kotlin helps us to turn it to something more readable, more understandable. So, okay. At that moment, let's check. Let's check. Maybe I'm saying no. Looks like it. Okay. I would say that in this, the huge example, we have a severe problem, kind of. The problem, what I would call it problem, the problem is that we have no separation between the creation of the builder and loading the data inside the builder. And I would try to say, okay, it's maybe not that good that I would like to have. And to solve this one, I want to create a function. I would call it build client, which takes some builder, which is supplier, consumer, Java 8. No? Java 1.8. OK, I'll explain. I'm trying to keep it closer to Java. So my pattern is Java client. So actually, my pattern is this function is used. So this function encapsulates the way how we create a builder. And then we have a lambda, which actually fills up the state into the builder. In the pure functions, we would rather say the lambda should return some state in some object. But OK, for now, we say, OK, let's have some side effects. And so we create, so now I can copy paste something here. So I create this builder. I call it accept builder. And then I try to say builder, give please my, and I want to return this result to the back here. Java, not company builder, but Java client. And I was saying that I explained what consumer is. In Java 1.8, you can use lambdas as well. And there are functional interfaces, which namely interface with one function inside. And the consumer is interface from T, which actually have one method which accepts T. Like runnable, but with a parameter. Like callable, but without roles. So this one. And if you use Java 8, you may use it in, say, in the collection stuff, in a number of other places. And now we can convert this, our existing code into the new one. Like we trying to abstract the way how we create this client builder. And so I'm simply say the client is build client. And here I create an anonymous object in Kotlin. Consumer from builder. And the method inside. And I'd rather call this from T. I would call it builder. And now I employ my favorite part. It's not about the copy pasting, but it really helps. What we achieved. So we now moved the part inside. So now the tiny function, which may reside in some factory, some stuff like, or even be created from some constructors or factories or somewhere. So it knows the trick how to create this class. And now here we only working to fill this with the data. So far, so good. In Kotlin, there is a number of ways how you create an anonymous class. So anonymous class is created via this syntax. You say object, you say type. And here you may specify a number of classes you want to implement. No matter it's anonymous class, for example, you may say, OK, I want to implement runnable for some reason. OK, go ahead, please implement the run method and it will work out. If you need this, OK, you may do it. But it's kind of boring. It's too long. And we can follow the suggestion to convert it to lambda. And we can follow another suggestion to simplify this one. So you can say, if you're dealing with Java classes, if this class has only one function, then you can use this syntax to implement this, to create an instance of this class from a lambda in Kotlin. But the good thing here is that we are not bounded with Java. So we are not going to backport this function into Java again. And it means that we can use the functional interface. So we use lambdas in Kotlin. And this one you do the following way. So you can say you have a function. So in parents, you specify all parameter types your lambda is accepting. So if you have a number, you can say, OK, something else, and that's all. And then you specify return type, and in our case is unit. Unit in Kotlin is the same thing as a void in Java, C, and other languages, so it's nothing. It's typed with only one value, technically. And here now you can simplify the call. You can simply call it as a function, as a normal function. From a Java side, this would look like a function one interface, which have one method with one parameter from T, but you no longer need to. And if you do this one, you can simplify our program this way. And there is yet another thing in Kotlin, and this is a really cool DSL builder thing. You can move lambda outside the brackets, the parents, like this. So the trick is that the last parameter of a function, if it's lambda, you can avoid it outside. So it would look like a language construct here. You see, you have no parents. Or if you have second parameters, you can specify it here. For example, you can say 1, 2, 3. Say I have a function which takes int and builder. Say, so for this function, int and builder, I would call it this way. And this forms an amazing building block. This helps you to implement anything you like. It will look like the language construction, but in practice, it means that it's just a function. For example, we have a synchronized function in Kotlin, which behaves exactly. The synchronized is a function. Actually, an inline function, but it's not that matter now. But it's how it is implemented. Okay, now let's move on. Need this one, I guess. Need this one. We can simplify this thing, and we can rename it to it. And the trick is that the it is a default name for parameter if you have a lambda from one parameter. Well, what I don't like here is this part. I don't like this. I like to be able to say this. Well, as long as I build in this object, I'm filling it out, why should I always say it? No. I want to do this way. And let's compare two things here. I would even, we don't need private here. I would just copy it here to show. You see here, the first one, this one, is an extension function for an object. But as long as we have an extension function for an object, why don't we have an extension lambda? Or it's called lambda with a receiver. So this is a lambda of the same thing like here. We are losing. Okay. Where is my example? This is a basic. So this is an infix function, and some lambdas as well. So this is a print. This is a function which takes int from one side and a string from the other side. And this is the lambda with the receiver. You see? You see the declaration here? It's done this way. Okay. I'll explain it here. It'll be easier. So for now, what I do, I say the one parameter of my lambda is moving from here to here. So this is how you declare the thing. So you say the parameter type, and in parents you specify the other arguments if you have some, and the return type as well. So you may call it this way in the usage, but the more understandable way would be this. So it behaves like a member, but it's not a member. It's a function call which takes parameter as a parameter this instance. It's a little bit trickier. But what we can achieve out of it, we can have it work. So instead of it, I no longer have it. I no longer have a parameter over here. I cannot say this one, because this lambda has no parameters anymore but a receiver. So instead of it, I would say this. But it's boring to say this in this context. So I would say just this way, that way. OK. So now we made it look a little bit better, but we have two problems. One is here, the second is there. And how would I fix it? In my case, I would create an extension function for a builder to implement yet another builder. And in this case, I would create Java builder. I would call it Twitter. And this one would take builder, which is Java Twitter builder. And it will not return anything as long as I would just fill up. So the code would look like this now. So I would say do you see how to implement this one? Oh, yeah? Yes, please? Yeah? Oh, yeah? Mm-hmm. Oh, no, no, no. Yeah, you're right. So we just fill the field, right? Oh, thank you. Let's try to implement the second one, but within one expression. Any ideas? I'm just start copy pasting the stuff to prepare. So we wanna implement this one. We are one expression, so I say company equals to okay. What? No. If you call Buildi here, I use here. But anyway, if we call Buildi here, it returns unit, so it will not work out. Yes. So others, please say. Any other ideas? So, yes, please. Yeah, true. That's it. It's kind of an easy magic. So first of all, we're now able to apply this apply. And I just take this tiny part of my code and put it here. I no longer need. Well, first off, I would say this is kind of a good tweetable DSL we created to fill this object model. So now if I would share this one to accountancy or to any other departments, I would expect that they, even if they have no idea what this Kotlin, Java, JVM, JavaScript stuff is, they are likely to understand what I'm trying to say here. Well, I hope the equal sign will not frighten them, but this is the problem. This is how we may turn the ugly object model. So let's see what we have at the very beginning. The Kotlin example, this is Java client example. So we started with this one, and I have no idea how many tweets it did. Oh yeah. Yeah, let's try. But it's too long. Split it vertically. So this is one thing, and that is yet another. Works so far? Oh yeah. Oh, what a good screen. We need a wider screen. Okay. And now it's time to dig deeper inside what's this apply. Any ideas? That's true. So it's as easy as this one. So I would copy paste it to my code, and I slightly simplify it to avoid, for the sake of understandability. We no longer this one. We no longer contract here. This is what we do. And of course, if you have a function type in your program, it behaves like a normal object. So if you have another function which takes this function type, so go ahead and pass it directly. Of course, you can pass it indirectly. You can say like this. But well, it reads longer, but still possible. I don't know. I have no idea what. So, in case you have different functions of slightly different types, of course you need to have a lambda, extra lambda. If the types are the same, you. And the second trick about this apply, so this calls this inline. The inline makes the compiler, says the compiler, please inline this function in the call side. It means that while inlining, it will ruin out this lambda. So it will have just a linear code. So I mean that this one would on the compiler level would look the same as that one. And try to see the Kotlin bytecode. Anyone like reading bytecode? Oh, sometimes it's really interesting because, for example, there is no final in the bytecode level. But I have a decompile button here. And IntelliJ will try to show me something like Java-ish from a Kotlin. And let's see here, this one, the Twitter function. And Kotlin is thinking something can go terribly wrong. That's why there are heuristics. So it checks anything for you behind the curtains. And this one, this is a function, the first one. And this is the result of inline, the supply inline function. You see difference? Well, you should not. The only difference is there are different types. There's Java Client Builder, and here is Twitter Builder. That's only different. But technically, the inline function do this trick. And if you, for example, you may implement something like lock and lock pattern using this one with zero overhead. Quite kind of powerful. Okay. Questions so far? Let's a little bit relax. I also some pictures. No, it's not about relaxing. Sorry about this. This is about learning. So the last link is the best. So if you're trying to figure out how would you try to create your own examples, you may either ask me or you may read it in types of builders. You may Google Kotlin types of builders, and you will see the really cool example on how you deal with the lambdas with the receivers, implement the whole. Of course, lambdas and extension functions are the concepts you may take a look. And if we now turn back to this HTML, and I want to ask you if you say, do you see how would one this HTML function? The trick is that we oh yeah, so HTML is a function which takes lambda with a receiver and type HTML. The type HTML contains all blocks, all elements we have here. And this is the main building block. So the trick is that this HTML function, it creates inside, it creates the builder which knows how to build the rest of the HTML. And then it calls your function having this builder as the receiver. So you mean that you no longer need to use it or this or something to call the next methods. This is how, so the head is yet another function which is declared in the HTML builder, which takes yet another function which has which has a builder with a receiver, and the receiver has the property title, and so on. The trick is that we need to call some method to put the string contents inside the block. And the plus is the overloaded unreplaced operator. Instead of having this one, we may call it some add, include, write, something. But, well, for the sake of simplicity or complexity, so we use plus. If you like, you may use minus. Because, unfortunately, there is no unary division or unary multiplication operators, but plus and minus are. And for example, if you're trying to create a DSL for JSON, well, you may use the division, the mod operator, the percent operator, to implement it instead of dot, instead of colon. Well, it's up to you. And this stuff is implemented as a Kotlin HTML library. So if you want to dig deep more, you can go ahead and take a look. And you may compile this one into two backends: JavaScript, JVM, and others. So this is a pure Kotlin code, compilable. I want to show you one more example. So I was digging into Guava sources, and I saw this pattern. So if you have some object with some state and logs, you try to figure out whether you're trying to mutate the state under the log. Do you? It's kind of an easier thing to have bugs. If you have a log and some field is supposed to be read or write or read under the log, but it may not. And to overcome this one, you may create some annotation and some static checker to make sure it works for you. But instead, you may do the following trick. You extract the state in a different class, and then you create this guarded by class, which has the operator invoke, which takes a lambda with a receiver. It means that you are only allowed to access this state via this call. Let me try to show it here. OK, so what I have here, I have created the field. So this is a class where I have a mutable state, and I want to make sure this mutable state is accessed only under a log. Say read-write log or synchronized, no matter. And how would I do this? So here I created the class which called guarded, and this one is a call of a function. Here you see, this function takes a log, and it calls my lambda. Clear so far? I'm trying to make sure that you're following this. And then what we do here, we say, OK, we call the function, and inside this function, I see the fields of this class state. And it means that if I try to implement some wrong function, I cannot say shutdown, for example. There is no shutdown here. There is no running tasks. So the only way to access this state is to call a function on guarded. So I call guarded, invoke, and pass inside this one, I see the values. One more trick over here called invoke. Invoke is an operator in Kotlin. I use a specific keyword operator over here. It means the only thing. I can omit this one, have it this way. I may have another function, so with another parameter, so this is also a valid thing. So I may pass here additional parameters if I have some. If you now say, what is the overhead of this? And normally the overhead is a new class, new lambda, which is created on every call. It's not good. But if you go here in this invoke function and use inline keyword, the whole thing is being inlined over here. So if we try to take a look on the bytecode over here, we see that it again does nothing. So anything is inlined. You see here, this is the wrong function I created. So what it does, takes the lock at the first, then calls my code, which I call, and then it unlocks it finally. So there is no overhead, no matter if I use in lambdas, thanks to inline function. Okay, so the slide showing this. I think it's good that I haven't covered some other operators. You may call the you may have Infix function, like you saw a print in basic example. You may call lazy, so by lazy, it's a really cool thing. You may delegate the properties via extra function. For example, you may cache. So by lazy is the function. Lazy is a function, by is the keyword. Makes the value of x being executed only once, computed only once, and then you use the cached value. Only one line. You may use the delegated implementation. If you have some interface with 100 of methods, you may use the by keyword. Say B has hundreds of methods, and the C is an implementation, some instance of B. I may say this. So I implement an object A, which delegates all methods of B to instance C. Well, it helps a lot if you're trying to deal with some existing interfaces and framework. There are mostly the same things, so the typeset builders I really recommend taking a look. Delegated properties is about this by keyword for a lazy implementation, and operator overloading helps you to create your own. Like here you see, you may implement your own plus on your own types. For example, in Kotlin we have a plus operator implemented for a list. So you may write list plus another list, and it works. Or list plus another element, it works as well. And depending on if you have a mutable list or a mutable list, it works different. Okay, so if you try to create your DSL, what I did, so I created some DSL, then I evaluate if it works okay or not, if it's ugly enough or not, and so then I repeat. And then you understand that there is a timeout exception, and then you throwing it away and using something that you haven't done in the middle. This is how it works, and this was like a tiny experiment. And the trick here is that the infix function. So infix function, you call the print, which takes the left side. Actually, the print function here is an extension function on type print, which takes string. And you use the infix keyword on the left to say, OK, I allow such a trick here. So, oh yeah. So I would go here. So here's the print function. I navigate here. You see here the infix keyword, fun int return string. Actually, the whole trick with basic, it even works somehow. You see here there is a main. I can't recall what it does, but I think it prints something. Is it? Oh no. Oh, it's. Okay. The first thing we need to. Boring. More. Wow. Well, supposedly it works. And the whole thing is less than 90 lines. That's it. Okay. Switch here. Okay. If you're bored enough, I hope you will never ever use such a DSL in production. Oh yeah. Several tricks about the existing DSLs. So this one I created some time ago. The idea was to use the Kotlin expressions to mimic something like XPath queries. And as you see here, that JXML is an object which has an overloaded operator division, and so on and so forth. You may implement the XPath queries. And then you pass this object into a loader, which evaluates these queries on an XML and loading this data into this key and value field. And the type of key and value is defined by the thing you use on the right. So for example, here the type would be string, and there is another element which creates a type of list of something, for example. You may take a look on this GitHub. You've shown today some examples of a Gradle script Kotlin. If you use Gradle in some future time, you would be able to use the Kotlin to implement your build. And I personally think it's a great idea, because in Groovy, you are sometimes so easily may shoot you on a foot, forgetting something, doing something wrong. from one hand. From the other hand, IDE has no idea about what you are doing in the third closure inside, because it's tricky to understand. And here, IntelliJ or Eclipse will show you the exact types, and you figure out what. If you're using TeamCity, you may define your build plans, or build configurations with the DSL as well. In Spring 5, there is a really good thing. You may use the DSL to define your controllers, and I guess more. There is a BDD testing framework. On the right, you see an example, which is built on top of Kotlin and DSL. So it helps you to define how you do your BDD testing. Pretty nice. And of course, there are more. You may take a look at this link. This is a really helpful one. It lists some blog posts or repos with the details. And the last thing I want to show, if you're learning Kotlin or you have a question about the Kotlin, kotlinlang.org is a really good place to start. We have a good documentation in there, and we have a Kotlin coins. This is a tiny website. It's 40, 50 tasks or small exercises. You may try solving this either from the web browser or from an IDE. There is a plugin for IntelliJ, I guess. And you may learn the Kotlin if you have no chance to try it in practice. You may start learning it from coins. And if you have questions, you may try Kotlin Slack. And last time I checked, it was 12,500 people in there. So there is a high chance to get your questions answered if you write in there. And there are a number of channels in there for Spring, for native, for anything else. And for meetups, I guess. And that was my side, my part. Well, I'm here to answer questions.
Oh, yeah.